So I want to give a little argument for why this very important theorem is true. Why is it that the dot product captures so much about length and angle? And so here's the diagram that we have of a vector u and a vector v, and there's an angle theta that sits between them. And the theorem says that u dot v is the same thing as three things multiplied together: the length of u, the length of v, and the cosine of the angle in between. And this is very useful for finding out the angle theta between two vectors. I want to show you why this is true. And where this comes from an old trigonometric fact called the law of cosines. Maybe you've seen this before. So let me remind you what the law of cosine says. The law of cosine says, suppose you have a triangle. Okay, so I have a triangle, and maybe it's not a right triangle. Okay, many triangles aren't going to be right triangles. And I have side lengths side lengths A, B, and C. And suppose I know the angle that sits between A and B, call it theta. Okay. Please notice how similar this is to the picture above. Then what the law of cosine says is it says that it's almost the Pythagorean theorem. It says that c squared is a squared plus b squared. If I stop right there, that would be correct in the Pythagorean theorem if the angle theta was right, if this was a right triangle, but it might not be a right triangle. And when it's not a right triangle, there's a correction term, which is minus 2 times a times b times the cosine of theta. Okay, so this thing here is called the law of cosines, and this is why the theorem above is true. Okay, so I'm going to cast the picture that we have right here, this picture right here, in terms of the law of cosines, and what's going to pop out is exactly the thing we want, that is this identity. Okay, so that's the strategy. So let me show you how we do that. So what I do is I consider my picture that I had before. I have a vector u, let's say it's right there. I have a vector v, let's say this is v. And of course there's an angle in between them. So here's u, and here is v, and there's some angle in between them. What you do is you complete the triangle, right? You want to have a triangle, so you can do a law of cosines, and there's an obvious way to complete the triangle just by connecting the tips of these vectors. So I'll do it this way. I'm putting it off skew a little bit so you can see where I'm drawing it. And of course, as we know so much about vector operations, we know that this is the vector u minus v. So there's a triangle. The missing leg is u minus v. And I'm simply going to put in the law of cosines. And the law of cosines, this would have been the C, this would have been the A, and this would have been the B, would say that the C length squared, but that's not u minus v, that's actually the length of u minus v being squared, is the length of u being squared plus the length of v being squared minus twice the length of u times the length of v times cosine theta. And all we do now is remember that length squared is a vector dot with itself. So if you remember this fact, for any vector w, w dot w is the length of w squared. So all we do is we use that several times. Okay, so let's just write this out here. So the length square of u minus v would just be u minus v dotted with itself. And the length of u squared would of course be u dotted with itself plus the length of v squared, which is v dotted with itself, minus twice the length of u, leave that alone, length of v, leave that alone, and cosine theta. Okay. Now, the only trick, and I hate to call it a trick because it's not a trick, it's just a mathematical fact, is I'm going to now distribute these terms and FOIL this out. FOIL this out, which is a legal move with the dot product. So if you FOIL this out, you get u dot u minus u dot v minus v dot u plus v dot v. And I'm just working on the left-hand side. Don't worry about the right for right now. But of course, if you recall, the dot product is commutative, so v dot u is the same thing as u dot v. So when you make that switch there, the left-hand side is just u dot u minus twice u dot v plus v dot v. Right? But don't forget, there's also a right-hand side. And the right-hand side is u dot u plus v dot v minus twice the length of u, the length of v times cosine theta. And now I'm going to cancel. These are equal, remember? These two sides are equal to each other. But u dot u occurs on both sides. V dot v occurs on both sides. So what we're left with is negative 2 u dot v is equal to negative 2 length of u, length of v, cosine theta. Haha, cancel the minus 2's from both sides. And what do you get? You get what I claimed is true. U dot v is equal to length u, length v times cosine theta. And that does it.